Hey everybody, in this video we'll be looking at how to determine the time for an investment to grow to some specific amount. So for exercise 8.04, we're going to do question 9. Zara has $4,000 in an account earning 4% per annum interest, compounded yearly. By guessing and checking, determine how long it would take Zara to double her money, give your answer to the nearest year. So we know a formula being A is equal to P times 1 plus r to the power of n being a compound interest formula. Our principal is $4,000. That's sitting in the account earning 4% per annum interest. Okay, so we're going to substitute that in, but also it wants the account to double its own money. So if we make P $4,000, then A would be double of this, and that will be $8,000 times 1 plus the rate, that will be 4% per annum, and that's the same thing as 0.04 raised to the power of n. Okay, so what we've got to do here is we've got to use the guess and check method and figure out what the value of n in this case is. But first of all, before that, I'm just going to simplify what's in that bracket. So that 1 plus 0.04 gives us 1.04, like that. And I'm just going to have a start to guess of how many years it would take. Okay, so let's just say I put in my calculator 4,000 times 1.04 to the power of 10. Okay, I'm just going to have a guess. And what we're trying to aim for is this answer, whatever it is, has to get to $8,000 or slightly above that. So if we have 4,000 times 1.04 to the power of 10, I will get 5,920.97 and so forth. So that's not going to be 8,000 yet. So let me raise it up even more. I'm going to raise this to maybe 15. Okay, so on the calculator, all I need to do is delete that 0 that I had before with the power of 10 and change it to 15. So now what I get is, I'm going to get this. Hold on. I'll change this to 15 by writing it here. Okay, and that will give us 7,203.774, so on. Okay, that's almost 8,000. So I'm going to slightly adjust it, so I'll make it slightly higher. And then all I'm going to do on my calculator now is just increase the value a little bit. So if I make it to the power of 16, it gives me 7,400 something. Now if I get it to power of 17, it's 7,700, and power of 18 is 8,100. So when I raise it to that power, okay, I'll get this number here, which is the first number that I get that is above 8,000. Okay, whereas a power of 17 still give me something in the 7,000, so that's not correct. All right, so our answer for this one is n is approximately 18 years for the amount of $4,000 to grow to $8,000. Let's have a look at one more question. Question 10. How long to the nearest year, meaning we got to find n, with an investment of $2,400, that is our principal. I'm just going to highlight there. Will take to grow to 3,265 at 8% per annum interest compounded yearly. Great. So let's start with our formula. A equals P times 1 plus R to the power of n. You want A to be this amount here, which it grows to, and P, which is 2,400. So we're going to substitute those two values in and times that by 1 plus the percentage in decimal. Okay, so 8% is the same thing as 0.08 raised to the power of n. And again, what I'll do is I will simplify what's in that bracket, just make it look just slightly nicer, and make it easier for us to type in our calculators. So now let's have a guess of what number that may be. So let's have a guess of, let's say, number 6 for now. So 2,400 times 1.08 to the power of 6. I will get 3,808 Ex8.0498. But hold on, that is higher than this. Okay, but is that acceptable? It may be, right? So we're just gonna decrease our power down by 1, okay? So that we can get 3,526.38. So fourth, that is still higher than this number, but we want to get the first value that's lower than this number to indicate our best choice, okay? So if I now decrease that by 1 power and I get power 4, I get 2,400 times that power 4, and that will be 3265.17. Okay, and just to make sure that it is the most correct answer, I'm just going to decrease it to power 3, and that will get me 3023.30 dot dot dot. So you can see here that the first power for the number of years, okay, belonging to 1.08, that will get me a first value that is higher than this value here of 3,265, would be this one here. Okay, that's the first value that's higher. So that's the most correct answer. So therefore we can say N is approximately 4 years.